Hi, welcome to lesson 15, session 2. We will be continuing our work multiplying a decimal by a whole number. We'll be developing new strategies that we can use, or new and old strategies that we can use to multiply a decimal by a whole number. We'll be working in our Ready Classroom Math workbook on pages 313 through page 318. If you're ready, you can go ahead and turn with me to page 313 in our Ready Classroom Math workbook. All right, so we're just going to continue what we were working on yesterday, which is multiplying a whole number by a decimal. So let's go ahead and read the problem first. The problem says, Padma bought 3 pounds of grapes. Each pound of grapes cost $2.75. How much money did Padma spend on grapes? So first of all, what is this question about? The question is about pounds of grapes. And what are we trying to solve? We're trying to find out how much money Padma spent on grapes. And then finally, what is the important information? She bought 3 pounds and each pound cost $2.75. So to solve this problem, if you would like to try and do this on your own using one or more of the strategies that we used yesterday, go ahead and pause the video and solve this on your own, and then unpause to come back and see if you used the same strategy that I used and if you came to the same result. Okay, so we learned yesterday we had 2 different strategies that we used. The first strategy that we used was repeated addition. Now, I would say that this strategy will work just fine if you don't have to repeat the addition a lot of times. So in this case, if we have 3 groups of $2.75, using repeated addition of $2.75 added together 3 times, that's not going to be that difficult to do. When it's going to be hard is if you were multiplying $2.75 times 72 pounds of grapes. It would definitely be a much harder number for you to do using repeated addition. But in this case, it's something that you can do. So one strategy would be a repeated addition. If we were doing our repeated addition, we would make sure that we line up all of our values by place value. Our decimal would drop straight down. Since we are adding, remember it's different when we're multiplying, but when we're adding, it drops straight down. And then we would add each of our place values. 5 hundredths plus 5 hundredths plus 5 hundredths is 15 hundredths, which I regroup and add 1/10 up to the top. 7 plus 7 plus 7 is 21, plus 1/10 is 22 tenths. I put 2 tenths there and I regroup 20 of those tenths to add 2 more up here, and then 2, 4, 6, 8. So Padma spent $8.25 on grapes. So that's one strategy that you could have done. Another strategy that you could do is partial products. You could also do standard algorithm. I'm going to go ahead and show the partial products, but you could also do standard algorithm. So if you're thinking about the problem, what we have is we have $2.75 times 3 pounds. So we could multiply it out and find our partial products. Now, another way to think of this, well, I'm going to keep going with this route. Okay, so my first partial product is 3 times 5, which is 15. Then 3 times 70, because I have my 7 there, which is going to give me 210. And then finally, 3 times 200. 3 times 200 equals 600. Then I'm going to add up all of my partial products together. 5 plus 0 plus 0 is 5. 1 plus 1 is 2. And then 2 plus 6 is 8. Now, right now, I don't have a decimal point in my answer. So remember, we need to look back at our original problem. And we have 2 digits that come after the decimal. So in this case, our decimal needs to be moved over 2 places because this answer here is hundredths. So we need to move our decimal over 2 places, which is going to put it there, and we'll still get our $8.25. One other thing that we could do if we wanted to think of this is $2.75 is the same as 275 cents. Because if we think of this all as a whole, it is the same as 275 cents. If we multiply that times 3, and then let's just use standard algorithm in this case. 3 times 5 is 15. 3 times 7 is 21, plus 1 is 22. And then 3 times 2 is 6, plus 2 is 8. So our answer here would be 825 cents. Well, I know that there are 100 cents in $1. So I know that this is the same as saying 825 hundredths. And so if I wanted to show 825 hundredths, that would be the same as 8 and 25 hundredths. So that's also another way to look at it. All right, let's go ahead and move to page 314. On page 314, they're showing us 2 different ways that we could do this. So we have, these are called decimal grids. You can use decimal grids to picture multiplying a decimal by a whole number. Think of 3 times $2.75 as 3 groups of 2 and 75 hundredths. So here we have one group of 2 and 75 hundredths, another group of 2 and 75 hundredths, and then a third group of 2 and 75 hundredths. If we added each of these up all together, we would end up with our same answer of 8 and 25 hundredths. But we'll go into that a little bit more in just a moment. You can use partial products to multiply a decimal by a whole number. So this is what we did on the last page. So we multiplied $2.75 times 3. So the one thing that they did here is they added the place values in. So we multiplied 3 ones times 5 hundredths, which gives us 15 hundredths. Then we multiplied 3 ones times 7 tenths. And 3 ones times those 7 tenths gave us 21 tenths because 3 times 7 was 21. So that gave us 21 tenths, which is the same as 210 hundredths, which this is a little wordy, but just bear with me. So 21 tenths plus that 0 makes it a hundredth. And then finally, 3 ones times 2 ones is 6 ones, but we know that if we're writing it in hundredths so that they all have the same place value, we would need it to be 600 hundredths. So this is just another way to think about it, but I think that if you guys don't think too hard, you'll just do it naturally. So we got to our answer of 825 hundredths. So remember, another way to say $2.75 is 275 hundredths. So if we multiply that 275 times 3, we're going to get that many hundredths. And then we just need to place our decimal. In this case, if it's 825 hundredths, we need to make sure we place our decimal where there are the place value after it ends as hundredths. So all we did was place the decimal where this would say 8 and 25 hundredths. So the place value didn't change. We just placed the decimal where it would go between the tenths and the ones. Go ahead and go to page 315. To solve the problem, so now we will use the problem from the previous page to help us understand how to multiply a decimal by a whole number. To solve the problem, you need to find 3 times 2 and 75 hundredths. So if we wanted to estimate the total cost of grapes, what would we do? So I know that $2.75 is really close to $3. And it's super easy. Oh, this is not, there we go. It's super easy for us to multiply a whole times a whole. So what is 3 times 3? We all know. 9. So we know that our answer is going to be about $9 because $2.75 is close to $3. And then $3 times 3 pounds of grapes equals $9. This is really not liking, there we go. Now, if we look back at this picture, and you've got kind of have to like bear with me here because we're gonna do some combining. We want to see how many full grids we can make. So right now we have 1, 2, 3, 4, 5, 6 full grids. And then we have 3 grids that are partial. But guess what? We can actually take some of these partial grids and put them together to make even more full grids. So I'm going to use this grid to fill in my other 2 grids. So let's see what we can do. So this grid here is missing 24. So I'm going to take away 10, 20, and then 1, 2, 3, 4. So and that's gonna fill in all of that. So me taking that away from that grid there made this my 7th full grid. Now let's see if I have another 24 to fill this grid over here. So I'm gonna take away 10, 20, 1, 2, 3, 4. So that's going to fill in all of this, and that's going to give me my 8th full grid. Now, is there a way for me to fill this grid and make it full? No, we've been using it actually to take away, so there's not much that's left in this grid. So we had enough to make 8 full decimal grids. Now, how many squares should be shaded in this final grid? That's what we have left. So let's count and see what we have left. And we might have too much left. We'll have to look and see. All right, so we've got 10, 20, 21, 22, 23, 24, 25, 26, 27. We have too many. So what did Mrs. McGuire do wrong? Oh, you know what? I was supposed to borrow, I found my error. I only borrowed 24, but I actually needed 25 in order to fill each of these grids. My apologies. So I needed to take off 2 more of those. Now it's right. I realized very quickly that my answer was incorrect. So now let's count how many we have. We have 10, 20, plus how we have 2 tenths and how many hundredths? 1, 2, 3, 4, 5. So we have 2 tenths and 25 hundredths, or we have 25 squares that partially fill this grid. So then, looking at the model it, so now we know that we have 8 full grids and 25 partially filled grid, or 25 of these hundredths left over. Now, if we look at the model it, this lesson down below, how is multiplying with a decimal like multiplying a whole number? Oh, and I should add right here, if we added those 2 together, we have 8 wholes and 25 hundredths. So that gives us our $8.25. Now, looking at the model it, how is multiplying with a decimal like multiplying like a whole number? That's kind of what I showed you down here, down below in this partial products, and then also in when we think about the number a little differently. So the process is the same. You just need to decide where to place the decimal point in the product. So we're going to do the same exact long multiplication problem that you guys learned how to do a few months ago. The only thing that's left is to figure out where to put that decimal point when we're all done. So if we have 8 and 825 hundredths, how many ones is that? Well, that's telling us that we have 8 ones and 25 hundredths. So we have 8 whole numbers and then 25 hundredths of another whole. This is the part. We just got done with fractions, and if you were thinking about fractions, this would be the whole number, and then this would be the fractional part. So we have 8 and 25/100 ones. Now, both the picture and the model, it show that 3 times $2.75 is $8.25. Now, is this product reasonable? So thinking back to our estimate said that our answer would be around $9, and we got $8.25, which is totally close to $9. So yes, $8.25 is close to my estimate of $9. It's definitely a reasonable estimate. Now, explain how to multiply a decimal in the hundredths by a whole number. So what we'll do is we'll multiply as we would with whole numbers. The product or the answer will be in hundredths. So remember, looking down here below, or back, let's look back on this page. When we looked here, we multiplied cents, remember, is the same as hundredths because there are 100 cents in $1. So 275/100 times 3 wholes equals 825/100. So you're going to multiply just as you would, but then remember your answer's in hundredths. If you want to make your answer back into ones, then you have to move the decimal place. So looking at our strategies, what strategy do you like best when you are multiplying a decimal times a whole number? If you like to use standard algorithm, that is using this down here, you could say I prefer standard algorithm. You could say I like partial products. You could say I like using decimal grids. You get to pick. So go ahead and tell me the strategy you like best and why. You can pause the video and fill that out, and then when you're done, you can go ahead and turn with me to page 316. All right, we're on page 316. So we're looking at all of these, and we're going to do numbers 8, 9, and 10 together. So number 8 says, onions cost 65 cents per pound. Sasha bought 4 pounds of onions. How much did she pay for the onions? Show your work. So this problem is talking about onions. We want to know how much Sasha paid for the onions. And we know that they cost 65 cents a pound and that she bought 4 pounds of onions. So what we need to do is we need to multiply 65/100 times 4 pounds. Now, when we're multiplying this way, we actually don't have to really worry about this 0. We're going to leave that decimal right where it is, but we don't need to worry about that 0 because we know that 4 times 0 would be 0. So really what we're only going to multiply is 65/100 times 4, not paying attention to that 0. So I'm going to go ahead and use partial products to do this problem. So the first thing I'm going to do is multiply 4 times 5. So 4 times 5 equals 20. And then multiply 4 times 60. 4 times 60 is 240. Then to solve the problem, I'm going to add together my two partial quotients. 0 plus 0 is 0. 2 plus 4 is 6. 2 plus nothing is 2. Remember, I don't need to worry about that 0. So now, my resulting, since I was multiplying this whole number by 100th, that tells me that this answer is 260 hundredths. Because when you multiply 100th times a whole, your resulting answer will always be 100th. So now I need to figure out where that decimal goes. Now remember, to show that something is 100th, there needs to be 2 digits past the decimal. So if I want to make this answer be 2 and 60 hundredths, I need to place the decimal between the 2 and the 60. So then it becomes 2 and 60 hundredths. So she spent a total of $2.60, or 2 and 60 hundredths. So the trick is just how do we put that decimal back in? And really it's just as simple as counting how many digits come after the decimal and then to move the decimal over from the right to that many places. Remember, we always start at the right and move the decimal place over, making sure that we know that the answer needs to be in hundredths and our answer is still in hundredths. Now, Brian makes a row of 11 paper clips lined up end to end. See these paper clips? If you put them like next to each other, he put 11 next to each other. Each paper clip is 2 and 48 hundredths centimeters long. How long is the row of paper clips? So this question is talking about paper clips, and we want to know how long is the row of paper clips. And we know that the important information is that there are 11 total paper clips, and each paper clip is 2 and 48 hundredths centimeters long. So we have our 2 and 48 hundredths, and we're multiplying it times 11 paper clips. Now up here I use partial product method. Here I'm going to use standard algorithm. So remember, for standard algorithm, we're just going to forget about that decimal for the time being. We're not going to worry about it. We're just going to do the math of 248 times 11 and ignore that decimal that's there. So first I'm going to multiply my ones digit. 1 times 8 is 8. 1 times 4, 1 times 4 is 4. Or 1 times 2 is 2. Then, don't forget, I need to put my 0 placeholder because this 1 does not mean 1, it means 10. So this one, by putting my 0 down below, that's saying that I recognize that this 1 here is actually 10. So then I can go 1 times 8 is 8, 1 times 4 is 4, and 1 times 2 is 2. And really, I was saying 10 times 8 is 80, 10 times 4 is 400, or 10 times 40 is 400, and then 10 times 200 is 2,000. That's why that 2's in the thousands place. Okay. Finally, I'm going to add that all together. 8, 2, carry my 1, 6 plus 1 is 7, and then 2. So my answer is 2,728. Is it? No. Don't forget to put your decimal back. We've got to put that decimal back in. So now we're going to look back at our original problem. And our original decimal, there's only one decimal in this equation because this is a whole number. And then I look at this decimal. How many digits come after the decimal? 2. So I'm going to move this decimal starting on the right, move it over 1, 2. So my answer is 27 and 28 hundredths centimeters long. All right. Finally, what is the product of 14 and 5 and 3/10? So I always like to put the decimal on top. It doesn't really matter, but I prefer to put the decimal up on top. So we're going to multiply 5 and 3/10 times 14. Now, we could look at this and actually already know what the answer is. That's how crazy the math is in this case. So why do you think we could just know what this answer is going to be? Think about how many digits come after the decimal and where our decimal should be in our answer, since we know this. Based on that fact, what should our answer be? All right, I'm going to tell you that I know right off the bat that our answer is going to be C. But let's check and make sure that I'm right, because I could be wrong. So let's double check. 4 times 3 is 12. We do different colors just because we've got 2 different place values. 4 times 3 is 12. 4 times 5 is 20, plus 1 is 21. Then I'm going to multiply my 10. But remember, I'm going to put my 0 down below. 1 times 3 is 3. 1 times 5 is 5. And then finally, I'm going to add the 2 together. 2 plus 0 is 2. 1 plus 3 is 4. 2 plus 5 is 7. I have one digit that comes after the decimal, so I'm going to move my answer is going to also be a tenth. So, was I right? Yes, I was. We could tell that what our answer was going to be simply because we knew since this was a whole number and this decimal was a tenth, that our resulting answer was also going to be a tenth. It won't always be that way. Tomorrow, for this week, it is, but starting on our lesson in 2 days, we're going to learn what happens when you multiply a decimal times a decimal. And that's when this easy, so like up here, when you multiply a hundredth times a 1, your answer is a hundredth. If you multiply a tenth times a whole number or ones, your answer is going to be a tenth. It will change a little bit, but at least let's just enjoy it for the next couple of days. Now you're going to go ahead and do the rest of the green pages. You'll finish on page 318. As always, if you have any questions, you can always email your teacher. Otherwise, I'll see you next time.